Let's talk about some of the subtleties about tests, terminology, and concepts that make hypothesis testing more precise. First, we're going to talk about type 1 and type 2 errors, and then in a continuation video, we'll talk about alpha, beta, and the power of a test. So these are a couple of book problems from Bach, Velman, and DeVoe, as usual. One is, well, paraphrasing. It says, testing cars. A clean air standard requires low emissions. State regulators check a random sample of cars that a suspect repair shop is certified as okay. They will revoke the shop's license if they find significant evidence that the shop is certifying vehicles that do not meet standards. So they're not telling us the precision, anything about exactly the mechanism of the testing, what they're testing, the numbers. We're just really talking about the concepts. And they ask questions like, in this context, what is a type 1 error? What is a type 2 error? The first, absolute most important thing, before even part A, I'm going to insert it right here, is we've got to make sure we know what the null hypothesis is. All of these concepts are relative to what you declare the null hypothesis to be. Okay. Well, the null hypothesis, H naught, it should be some definite statement that's usually kind of a status quo kind of statement. So, and in this kind of situation, probably the best null hypothesis would be that the shop is innocent and not guilty, or in other words, that the shop is only certifying the correct cars that really do pass the emission standard. Okay, and one way to tell, you always want to write the alternative hypothesis. For one thing, you want to be clear about whether it's a two-sided alternative or a one-sided alternative. Here it seems like a one-sided alternative is better. We're not too worried. We're not going to do anything if they're more restrictive than the state standard. We could give them maybe a bonus, or we could say, hey, back off a little bit. But that's not what the problem is about. Here it looks like the alternative hypothesis is that the shop's standards are more lax than appropriate, and they pass cars that shouldn't pass. And one way to tell that that's the null and the alternative hypothesis are chosen appropriately is that this thing is subject to some sort of variation in terms of degree. How much more lax? Okay, the alternative hypothesis usually is a less precise statement than the null hypothesis. The null is, okay, you are only certifying the correct cars. You have exactly the right standard, and here there's more lax. And we could ask, okay, well, are they really out of compliance? Do they pass everybody, or do they just pass it, let a few go that are just a little on the borderline? So that seems like a good choice of null and alternative hypothesis. Now we can start to answer the questions. A type 1 error, let's bring up the handy diagram from the book here. Okay, a type 1 error is when the truth is that the null hypothesis is really true, but you falsely reject it. You mistakenly reject the null hypothesis. Okay, so the null hypothesis was the shop is okay. If we reject that in error, we make a mistake, then this would be that we revoke their license unfairly. Okay, and so this is convicting the innocent. That's a good metaphor for a type 1 error. Another metaphor that they talk about is a false positive, like on a medical test. Okay, usually the null hypothesis for a medical test is that you don't have a disease or some sort of condition, and if you get the test back and it says yes, you have the disease, and that's incorrect, that's exactly an example of a type 1 error. It was really true, the null hypothesis, that you didn't have the disease, but they said, hey, told you to reject it and said that you actually have the disease. Okay, so a false positive here would be set off the red light and revoke their license when it's not appropriate. Well, what's a type 2 error? That's the opposite, as we see in this picture down here. That's when the null hypothesis is secretly false, but you mistakenly failed to reject it, just because there's always possibility for error in all of these things. Okay, that's what makes it statistics. So a type 2 error would be not revoking their license to conduct these tests, when in fact they are passing cars that shouldn't pass. Okay, we're too lenient. Here we're too harsh, we're inappropriately harsh. Here we were inappropriately lenient. Okay, so which type of error would the shop's owner consider more serious? To get this is kind of getting us an idea of why would we care about these things and how should we feel differently about these two types of error. Well, the shop's owner would care much more about the type 1 error. they don't want to lose part of their livelihood, revoke their license to do this part of their job unfairly. They would be very concerned about that. What about other people, like environmentalists might consider it more serious? They would probably consider the type 2 error more serious because they want the emissions to be as small as possible. They don't want a lot of cars on the road that shouldn't be passed. Okay, they don't want more emissions. One subtle point here is that they say might environmentalists consider more serious. I mean, the environmentalists probably don't want to be mistakenly revoking licenses for these places. That would cause problems as well. I think they would especially be worried about a lot of type 2 errors done systematically. And that's a kind of procedural worry. Suppose you're setting up the testing procedure and you set it up in a way where you ought to know you're leaving yourself open for a large probability of a type 2 error. That your test is set up so that you just can't really be that strict, and you're going to tend to err on the side of being too lenient. If that's systematic and you do this over and over again, and that's how you analyze these shops, then you're going to get a systematic case of lots and lots of type 2 errors happening. Okay, so and that's really I think the most important thing. You want to picture yourself not just doing this as a one-off. I'm just going to test one of these shops. I want to design a procedure that's correct. And there, it's a really big, serious issue. If you have a procedure that lets a lot of these shops go when you shouldn't, you actually really are going to get a lot more emissions than you should. Okay, I'm going to talk about this picture over here a bit more when we talk about alpha and beta, but we can talk about it right now. When we look at the mechanics of type 1 and type 2 error, what we got here, let me just click on this, is the null hypothesis is usually like some proportion. Okay, the null hypothesis is that the proportion of cars that they mistakenly pass should be quite low. Okay, and we're going to say this is the null hypothesis for innocence. And if in the null hypothesis, the actual distribution of what we're really going to get in a sample, remember, we don't exactly get the right proportion. We get some range of that. We get some range proportions around the true value. If the true value is P naught, this is the range we're going to get. They're going to be centered on P naught and with some spread. And a type 1 error is going to happen when we're up here in this tail. When it's really centered at P naught. The truth is that they're really not passing that many bad cars. It's okay. They're a good shop. But we accidentally, because of our random sample, we accidentally get a surprisingly high number of bad cars in our sample that they passed. That's where the type 1 error lies. Okay, so this tail is type 1 error. And we're going to see alpha is just the probability of a type 1 error. I'll talk about that more specifically next time. Conversely, how do you think about type 2 errors? You have to really change your mindset. Because remember, you actually are looking at two different mindsets for what's actually true. Here's the picture for where you're assuming the truth of the matter is that the null hypothesis is true and the proportion is centered on P naught, the null hypothesis value. The alternative is that there's some different value, some maybe significantly different value P. Maybe the proportion of cars that they're inappropriately passing is really quite large, and when I sample, I'm going to get values that are centered around that. When could I go wrong there? Oh, it could be if I'm way over in this tail. I accidentally get far fewer bad cars in my sample than I should, given that they're passing so many bad cars. That's where the type 2 error is. Okay, so here is where the type 1 error lies. Oop, I have to. It's in the upper tail, assuming the null hypothesis. And here, down here, is where the type 2 error lies. That's in the lower part of the tail, given the assumption of that the null hypothesis is false. Okay, we'll continue that in the next video.